Good day, ladies and gentlemen. I'll be taking a very brief topic, and this topic is energy quantization. But before I start, I would like to take you back memory lane. Prior to this time, you must have been taught about the different atomic models. There's this model that you were taught in the junior secondary where you have an atom like this. In the atom, we have a central nucleus. Then we have shells around it. Now each shell will have electrons on it. Is it true? Well, this model was propounded by one of our famous scientists in this world of physics. Well, it is from this model I will be making my inferences that we use to teach energy quantization. I'll be making reference to the Niels Bohr model of an atom. So very quickly, I'm going to redraw that. Here we have an atom, and this atom have some shells around it. A lot of shells, you see. Now these shells can also be called orbits, and these orbits have a particular energy that is ascribed to them. In other words, we can just say that an orbit represents an energy level, and each energy level has electrons that are inside them. I think that's a very simple way of saying it. For the sake of emphasis, I will repeat myself. Each orbit or shell represents an energy level, and these energy levels can accommodate some electrons. I'll be drawing very quickly the nucleus to show you what I am saying. Now that's the nucleus. So the first red circle around the nucleus will be the first energy level, then followed by the second energy level and the third energy level in this example. So the red is the first energy level, the green is the second energy level, and this will be representing the third energy level. I hope it is clear. Now when you look at this diagram very well, you will agree with me that the first energy level is very close to the nucleus. Very close to the nucleus. This energy level that is close to the nucleus is called the ground state. What do I call it? It's called the ground state. Now the ground state has electrons that it can accommodate. Now that doesn't mean other levels don't have electrons, they do, but the one close to the nucleus is the ground state. Now it happens that electrons can get energy, and when they get energy or absorb energy, they can move from one level to another. When this happens in physics, it's called excitation. And if an electron gets excited, it will move from its present level to another level. Let's say, for example, this electron in the ground state get excited. They will move from the ground state to maybe level 2 or maybe level 3, depending on the energy it has absorbed. I hope that is clear. Now, for emphasis sake, so that the whole concept can be clearer, we can actually represent these energy levels with horizontal lines. So I will quickly represent them with horizontal line. That will be level 1, representing the shell or orbit or level that is very close to the nucleus. That will be level 2, that will be level 3, that will be level 4. So we have level 2, level 3, level 4. Now we have atoms that can have up to 5 levels. Hydrogen, for example, has quite a number of levels. And that's why in physics, hydrogen is used more than every other element to describe energy quantization. So let's say I have an electron in level 1, which is the ground state level. It can absorb energy either by collision, that is when you bombard it with something else, it can absorb energy. Then when you absorb energy, it can move to level 2, 3 or 4, and we say that is excitation. So please do not forget this concept. Excitation is that process whereby an electron leaves its present level and gets to a higher energy level. Now, when it gets to its new level, let's say this time the level is maybe 4. Now, this electron will not remain in that level for life. After a while, after a period of time, it's going to come back to hopefully where it was coming from, or to a lower energy level. So if an electron returns back to its former state or to a lower energy level, we say it has gone through de-excitation. So de-excitation will be a process whereby electrons leave a higher energy level to return to a lower energy level. That is how this whole thing is. It means that for us to understand energy quantization, we just need to know just few concepts. One of them is talking about the orbits, which also represent an energy level. Then another one is excitation. Then the third one is de-excitation. Please don't forget those terms. These are the terms we are going to be querying when I see you in my next class. You need to know what excitation means. You need to know what de-excitation means, which I have defined already in my video. I just give you 2 more or 3 more facts, after which I will end the class. Then I'll prepare another video for you. Now, when an electron leaves a higher energy level and come back to a lower energy level, we say it has gone through de-excitation. In that process, it releases what we call a photon. It releases a photon. A photon is a packet of light or a packet of electromagnetic radiation. So it releases a photon in the process. And in physics, this photon is going to have an energy ascribed to it, meaning the photon has a value of energy that has been ascribed to it. This value of photon can be calculated. So energy of the photon is equal to H times F. That is what it means. Energy of the photon is H times F. Now in physics, H is Planck's constant. And Planck constant is 6.6 times 10 raised power minus 34 joules second. That's Planck constant. 6.6 times 10 raised power minus 34 joules second. So if I know the Planck constant and I know the frequency of radiation of the photon, then I can get the energy of the photon. So very, very simple. Now we can also do this in physics. I will use that line concept to explain it again. Now let's say there was a transition from 1 to 3, 1 to 3, electron moving from 1 to 3. And please let me write that very well. Electron moves from 1 to 3. So this is the electron at 1, and it moves to this position 3. That's excitation. Then after a while, it will go through the excitation to come back to either a level that is lower than 3 or to where it was coming from. Let's say this time it was actually coming back to 1. If I want to calculate the energy that has been used in that process, that energy can be calculated thus. Remember, it is moving from 3 to 1. So the difference in the energy level also represents the energy of the photon. So we can calculate energy of the photon directly as HF. And we can also calculate energy of the photon by looking at the difference in the energy level of the transition. In the example I just gave, there was a transition from 3 to 1. So the energy will be difference of level 3 to level 1 is equal to HF. Now this is how we calculate energy of photon when we are looking at this concept, energy quantization. Finally, I would like to say that the reason it is so called energy quantization is because this energy has a fixed value. It has a particular value. It has a specific value. So in physics, when you say something has a specific value, we say it is quantized. Don't forget, this branch of physics is, you can call it particle physics, you can call it atomic physics, and we use different terms in describing concepts in physics. So when something has a fixed value or a specific value,